few words about static equilibrium. Equilibrium means balance. So when we're talking about equilibrium, we're meaning that the forces are balanced. And in the spring, we'll take this to rotation as well. Static means not moving. So it means that the forces are balanced and that it's not moving. So the way for dealing with this, and a lot of the problems that you'll see are hanging weights, is you start with a free body diagram. So of our mass that's right here, we have a weight that's hanging down and two tensions that are going up. You're going to write the F equals ma equation for both the x and y directions. And because it's static, it's not moving, the acceleration is 0. That makes solving these problems nice. So we don't have just x and y forces. mg is just the y direction. That's pretty cool. But our two tensions are actually at weird angles. So there's a component that's in the x direction and a component that's in the y direction of each one. So you're going to use some trig in order to figure out what those components are. If you decide to draw components on your free body diagram, you must make them dashed arrows. If you make them solid lines, the AP people think you've put extra forces on your diagram and they take off points. So it needs to be dashed, and that lets the AP people know that it's a component of a vector. And then once you have your force equations, you solve those equations in order to get what you're looking for. So here's an example of the force equations for this particular drawing, where we have a tension 2 and a theta 2, a tension 1 and a theta 1, and then our mass here. So in the x direction, we're going to have the cosine of that tension force, and this is our angle right here. And if you need some help figuring out those components, whether it's sines or cosines, you can watch that video that I show how I did that. And then in the y direction, or sorry, and still in the x direction, I also have this one, which is cosine. So I made positive to the right. So T1 cosine theta to the right is positive. T2 cosine theta is negative. That equals ma, and then that equals 0. In the y direction, I have the sine components of each of these forces. So the T2 sine that angle, and the T1 sine this angle. And then mg is going in the negative direction. So I have T1 sine theta 1 plus T2 sine theta 2 minus mg is equal to 0. The rest of this slideshow goes through some examples of problems like this where I've solved those. So we have a person hanging from a rope. We've got some big ball next to a wall for some unknown reason, and we can figure out both the normal force and the tension in the wire.